Hello everyone and welcome to Handmade Hero, show where we code a complete game live on stream. Today we're going to do a longer stream than normal, so I might actually do 2 days, essentially. I might break, even though, day is the wrong term for Handmade Hero since it doesn't really equate to anything that's day related, but 2 sessions. So I'm going to go ahead and start doing some of the texture stuff that we want to do, and I want to try and do that basically in one big sort of changeover, but there's going to be a lot of work to do there, and so we're going to see if we can get it done into 2 long streams. Maybe we can, maybe we can't. It's anyone's guess, but that's what we're going to try. So this is going to be day 477. I'll probably break when this is done and then restart do a day 478. So we'll probably do 2 separate streams, separately labeled streams. I'm going to go ahead and get started here. For those of you who aren't familiar with what we've been working on right now, who maybe haven't been following for the past few weeks, we did an we basically pulled our renderer out into its own completely reusable piece that doesn't actually require you to be running Handmade Hero at all. And if you take a look here, we actually now have this pretty cool thing called Win32 Renderer Test. And when I run Win32 Renderer Test, you can see as we've got an entire Handmade Hero style scene that you can run completely separately. Now, there's a couple things that we want to do here and to finish off our renderer section. And I want to try and do that all today. So the first thing that we want to do is just fix our API for calling primitives. Now, I'm going to talk about that in a second, but we're going to dovetail that with fixing the renderer. So let me just show you real quickly where we're at on this, and then I'll talk about that. So what you can see here is if we open up our Win32 Render Test example program, this is an example of how on Win32 you could load and use our renderer very easily. This little demarcation in the file, all of this stuff is just some Windows code that for opening like a window, right? And loading a bitmap. So it's just a little bit of simple code that you need to start up your Windows application. Has nothing to do with the renderer. All the stuff for the renderer is basically right here. Here is our function that is called threaded at the moment. You don't have to call it threaded, but you can. So you call in here and you can see everything that you do. This is not related to the render. It's just a call to initialize some statistics keeping. Here is a texture queue. That's part of the renderer. You say, hey, I want a texture queue. Here is the render initialization, part of the renderer. This init test scene is just our demo scene, so that again is not part of the renderer. This is not technically part of the renderer, but is part of the utility code for render. You can just say, I want a standard camera that's like viewing a scene. And then we have some variables we set up. Inside the run loop, we just ask Windows what the size of things is, and then we use the utility function in the renderer to fit a 16:9 aspect ratio to it. You don't have to, like right here, you can just use rectmin max if you'd rather. So we actually support either aspect ratio fitting your window or not, depending on how your game wants to run. We then do some camera parameter updating. Again, this is totally up to the application. It has nothing to do with the render, it's just however the app wants to update its camera. We then do our renderer calls, process the texture queue, begin the frame. We want VSync to be off if possible, although it's not really possible in windowed mode on Windows 10. So it won't actually do that, but we're requesting it in case it can. We then begin one group of render calls. We say where we want to view the scene from. We push a scene on, we end the render group, we end the frame, and that's it. Very, very simple to use this renderer now, really simple to understand. Here's our push simple scene. This is the only other place we call the renderer. Here, 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 and here. And that's to put elements onto that's basically to put our primitives into the render buffer so they can be rendered, right? And so what we want to do today is we want to do a combined update. First, we want to update these functions to be more in line with a finished API, one that's been thought through a little bit and tuned. Because all the rest of our APIs now kind of have, and we have a pretty nice API now. So all of that wants to be, all of that looks nice. All of this wants to be as nice. And it's probably okay as it is to a certain extent, but it's not quite there yet. For starters, for example, we want to support rotation, and you'll notice we don't have a rotation sprite primitive in there now. So you see how these things collapse into 2D. That's purely how we're asking them to do. Like that's what we're requesting right now, and obviously we don't want that. So we want a primitive that supports rotation because it's easy enough for us to do. So we'd like to be able to support stuff like that. We'd also like these to be maybe a little more straightforward. They're kind of complicated right now in terms of how they're used, and maybe there's ways we could make that a little bit more sane. But then the other really big thing we want to do is we want these textures to be things that are faster than they are right now. So the way that we do our textures right now is very slow. It's really the slow part of our render in terms of structural aspects. These textures are created as separate textures, and in order to make those textures work quickly, we would have to count on the cards supporting bindless textures, which not all cards do. Certainly most modern cards do. A card that came from today would almost certainly support bindless textures. I guess I can't speak for like phone chips and stuff because there's a lot of those out there and I don't know that much about them. But I mean for big, basic gaming cards like you would see, even integrated graphics, I believe, will typically support bindless textures now. But as of, say, 4 years ago, it wasn't necessarily true. So there's probably a lot of cards out there that just don't. So in order to make this work better, I think what we want to use is textures arrays. I've said that before. Texture arrays are almost ubiquitous at this point. It's pretty hard to go back to find a card that wouldn't support texture arrays. So being able to turn these into something that's a texture array based thing would probably be really good for us. And so that's kind of where we want to go with that. And that's a big change to our API. I probably said that wrong. That's a big change to our renderer. It doesn't really change the API too much other than getting rid of one thing that I really wanted to get rid of, which is this part right here. When you load into the texture queue, that aspect there of having to do this feed forward thing, this feed backward thing, I wanted to fix, and we'll see that we could fix that a little bit later. But basically what I want to do here is I want to start looking at that texture array stuff and see what we can do about that. And I feel like there'll be a bunch of things we can do there. So that's really what we're looking at. Cleaning up those APIs, and as we do that, moving to a texture array system. And that will both increase our performance dramatically in the best case, and clear the way for us being able to do performance optimizations. But it also will just make the API easier to use. So all of that stuff I kind of want to do in one big push. That's our big push we're going to start today. Maybe we'll finish it, maybe we won't. But that's what we're doing. And that's really the last thing on the renderer before I would consider the renderer pretty good. There is a thing before saying it's finished, and that's the lighting, but we don't need to finish the lighting anytime soon. We've got some basic lighting in there. We can improve that over time. As we get our scenes together in the game, we'll ping pong back to the renderer to sort of make those lighting improvements and get something that we're happy with lighting. So that part is kind of a separate push at some point. It's not something we're going to do now, and it's not something that we need to have before we consider the renderer finished. I mean, for the purposes of this pass. Okay. So the first thing I want to do is let's just start with something really simple, okay? And we'll let this drive sort of our meander through the code base here and trying to make things work a little bit better, like I said. So at the moment, what you can see is when we've got these calls here, so one of our calls is push sprite. Push sprite, as you can see, it passes an x-axis and a y-axis. And one of the things that happens here when we're doing this is that because we're just using global x and y axes when we pass these through, you can kind of see how these sprites collapse. Now, why do they collapse? Okay, what's happening there? And again, this has nothing to do with the renderer because the renderer just thinks about quads. And so if you're just thinking about quads, it's impossible to get this problem to be the renderer's fault because the renderer is just rendering the quads you tell it to render. That's all it's doing. So that back end is not the problem. The problem is right here in the push sprite call. It's how we're constructing that quad. So if we pop over to Milton for a second and just do a little diagram so folks can be on the same page about what's going on here. Why are there two separate cursors? I don't know what's going on there, but I suspect it's not Milton's fault. That looks like a Windows thing. All right, well, anyway. Here's day 477. This is going to be camera matched quads. And so what you can see when we run this is there's a number of issues that we want to address in terms of how you specify these sort of upright quads, right? And you can see here that we sort of have a notion, you pass in a thing here that says what you want in terms of whether something's upright or not. And then what we do is if something is not upright, then we assume that you're giving us the actual axes for it. If something is upright, then we do this kind of like upright standing sort of separate thing that we do to make it look like a sprite card. And just to underscore the difference between those two things, what you can see here, if I take the tree and I change that true to a false so that it's not thinking it's upright right now, then what happens is when I run it, you can see that the trees are kind of flat lying on the ground. And furthermore, you can see the Z fighting happening there. That Z fighting is happening because those two planes are completely coincident. So the Z values of the tree and the Z values of the grass are completely equal theoretically, but because of the way iterators work, they're going to oscillate in discrete space to be slightly different, and that's where you get that Z fighting from, right? Any place where that's not happening, you don't get the Z fighting. Okay, so that's what happens if we take out that part of the thing where we go from the, we've got the sort of two different ways that can be called there with the true and the false. So the first thing that I'd like to do is I'd like to separate these two things out because I don't think we want one call for both of these things. I think I would rather have two calls because they're really two different things. I think I would like to have a push this is effectively a push quad or a push, I don't really know how to say it right, but a push 2D plate call, right? It's a thing that's going to do not this, right? So something that here you pass in and you just say, hey, if you want to create one of these sprites, we create one of these. I don't know what that ground P is. Okay, so that's just how we decided to position it. We decided it raises up off the ground. So the ground P part is not particularly relevant. This would probably turn into something else, like maybe this is a center P call. And so if you want to push a sprite where you just said what the x-axis, y-axis is, and so on, then, maybe it looks like this. And maybe this is, if I push a sprite on and I just want to say what the x-axis and y-axis are, and you just use those axes, then it looks like this, right? And that to me would be clearer. It's just a little bit nicer if we do it that way. The min UV, max UV thing, I don't know how necessary that really is in this case, because again, that doesn't really potentially need to be there. We could just assume that's 0 and 1. And in fact, maybe I will do that. For now, where we move that in like this, because the color is something that you'll probably always want to specify or often want to specify, but the min and max UV are probably not necessarily that. So we can have a lot of default parameters here because a lot of these things wouldn't have to be known. And so that way, when we do this, these can just go away, and if you want to specify a color, you can. And so, if you imagined us wanting to push one of these on here, we could just say, all right, that's a push sprite, and that pushes a flat sprite into with the world P. That pushes a sprite on with the world position and it's just the world axes, and whatever you specify are the axes that it actually uses, right?
And furthermore, we can make that a little bit more general there. Let me go ahead and where's our, what's going on here? No, none of this. Okay. So in here where we do our push sprite, don't ask me why I didn't just use the one that was over here. What you can see here too is the x-axis and y-axis come in as two-dimensional, and I don't really want that either. So the way that these work, right, where they're being pushed off, they're just assumed. They're just assuming certain things about how they work, and I don't really want to do that either. So what I'm going to do here is say that these are going to be used directly. And so this is if you just want a 2D sprite, and you know, probably most of the time you're going to specify that axis as well. So I feel like these almost want to be probably up here like this, because those are the more likely things to be specified. And these are going to be V3s. So this is a thing that literally takes a construction, a direct construction from you, and it goes from there. Don't ask me why I did that. There we go. Okay. Let's pop back here. These are just scales on this. So something like that. And we could just make it so that you actually pass these in scaled, but I'm just going to say for now, let's not do that because maybe we need them for other things. We'll see. Now, the Z-bias doesn't come into play here because no one has specified one, but I think we want to specify one. And so the Z-bias is also something that kind of, as the sprite goes up, you might want to have specified. The problem is we don't really know what should have the Z-bias and what shouldn't. So I feel like in this case, this has to be for non-Z-bias rendering. I just don't see any way to really get around that. Because we would need to have, I mean, I guess you could pass in what effectively were min UV and max UV kinds of things. And then you could use those as Z-biases, but I think this is basically for non-Z-bias rendering. So this is if you're just pushing sprites down in general, and you don't want to do anything fancy with them. That's this call, right? And I think that's roughly what we would want. We don't have much cause for that. We're mostly doing sprite cards in this. So I'm going to call this thing like a push upright. And it's just going to always do this. Oops. And this is going to have a little bit more teeth to it now, right? So when we call this function, what's going on with the Z-bias here? So that's actually set to a different thing. Looks like we edited that here. That's our current tuning, so let's keep that. There we go. And so I'm going to go ahead and make this look a little bit like its own separate thing. And so these folks here now are going to call this push upright call. They're not going to call the push sprite call anymore. They're going to call the push upright call. Let's get that going. And then we're going to tune that. And I'll switch the trees back to that too in a second here once we actually decide what the function call looks like. So now you can see we've got the grass going through there. The Krampus head also is, but we aren't looking at the Krampus head in that particular view right now. So that's fine. Now what I'd like to do is take a look at how we're doing that upright call and think about how we actually want this to work. So to start with, we look at what the calls are. Here's the base P that's on the ground that we're doing. Here's the size that we want to be. Here's the min UV and max UV. Again, those I think could come in here and really be more like defaults, because for us, they're always going to be these parameters, I think. For other people, maybe they wouldn't be if they're trying to pick sprites out of a texture atlas or something like that.
that they're using, they might want that to be the case. I don't know, but you know, that's their choice, and we can make that be something that they deal with later, right? Okay. So let's go ahead and run this now. So there's again the grass just being the way that it was, which is what I'm expecting. I'm not expecting to see any change here. So here we can start thinking about what we want this to actually look like now. So in addition to the x-axis and y-axis when we're working on this stuff here, what this also needs to be able to function properly is it needs to know what you expect the z-axis to be. Because right now it doesn't know. And it also, well, I guess that's not true. So we need a number of things. Really what we need here is to know what the camera looks like, right? We kind of need to know, like, what's the camera parameters for this scene so that we can face this sprite card towards it, right? So let's go over to Milton and sort of explain how that works. So what we're doing right now, and you can kind of see this, oops, that's not what I wanted. You can kind of see this with the way this is working, is we want to talk about a 2D sprite, but we want to talk about it in a 3D world. So we typically have something like, here is a cube or something that we've drawn, and we want to place the sprite on this cube, and we want to construct a sprite card that stands upright from the cube, okay? And we're doing that right now by a particular geometric construction that you can see here, okay? And if we skip this part just temporarily, and then I'll come back to it and explain what it does, for those of you who don't remember or never saw that part, all we do is we take how big you wanted this sprite to be, we multiply the input x and y axis by those, and we assume that the z coordinate for it was nothing, right? So we assume that we're going to use the x and y axis as like three-dimensional vectors that just have the first part in there, okay? And then we imagine, right, placing the points of the quad by starting at the ground position, which is here, going negative 0.5 along the x-axis, which is going to be this way, right? So we're going here, half the width in the negative x direction, okay? We imagine the min x, min y to be there. We then add the y-axis for the min x, max y, right? And then what does that do? Well, the y-axis, remember, this is z. Z is up. So y is like going out back that way. So this is going like over here and placing it here. Off in the back. Maybe I could even do it this way. Let's say y is that way and x is this way, right? Lying down. So it's going there. Then we're adding the x-axis for our max x min y, so it's going over here to do that. And then it's adding that y-axis again, right, to produce the max version. So if we did nothing at all, this sprite would be lying down flat like that. For the x and y axis. But what we do instead is we actually take the those x and y axis that we had. So again, if we assume that the world x and y axis look like this, then what we were producing is something that looks like that. If we take these axes and look at what's happening to them in this sort of upright code, this thing that does the modification upright, what you can see is we produce a second set of x and y axes, and those set of x and y axes actually use the y-axis as the z, okay? So we take the x-axis and we reinterpret it as if its y was going up instead of out, and we do the same for the y-axis. So what that does is it creates two sets of axes. These are the original ones, and here's the new ones. So, right, this part is still the same, but this part has changed, okay? Then we blend between those two, okay? Now let's keep going here because we actually actually, that's not true. Sorry. We blend between those and this modified one here. So we have to kind of talk about this one first, too, right? Okay. So in the render group, we also have the game transforms X and Y axes, right? And what that is that's, if you remember, let's just jump back to the... this right here is the camera transform. It's got the X and Y axes of the camera transform, right? And so what you can see us doing here is using the camera's X and Y axes. And what we're doing is we're blending between what the transform would be for the camera and what the transform would be for a purely upright sprite. Okay? Now, what that means is this is one set of axes, the ones that are just world X and Y. And then the other one is for camera X and Y. In order to draw what that is, I'm going to have to give a little example in terms of the camera. So let's say the camera's looking this way, right? Those axes are going to look something like this, right? And one pointing straight up at us. But the world ones are going to look more like this, right? Because the world ones are aligned to the world grid. So what we're doing is we're effectively blending some measure of where these things would be in absolute sense versus where these things would be in a camera sense, right? We're blending between those two things to produce the final transform. Now, what would it look like if we just used the full-on camera transform, right? I'm going to set the t parameter here to a variable, so we can see the difference pretty easily. So here I'm going to compile this and run it with the standard t. This is that. And what I'm going to do is first I'm going to show, here is if we just use the world axes. And if we just use the world axes, what you can see is that these things are locked to their world alignment. So as we rotate the camera, they're not following the camera at all. They're just purely cards in the world, right? They're purely 2D cards, fins, sticking up in the world. If I set this to 1.0, then now what we get is things that purely follow the camera, right? So here you can see that the grass is always pointing directly toward us, right? And so that's that 1.0 version, the one that's always facing the camera. That's really the one that we want to have so that our rotation works. But remember, there's a reason we didn't use it directly. It's because we want a little bit of that parallax, right? And we want a little bit of that attenuation, right? So this that was happening before to our sprites, that was the tuning we were wanting. The camera, by using a little bit of the world axes in addition to the camera axes, got that for us, right? This kind of thing. When we're looking here, we get this kind of bend. Now, why did it do that? Well, it did that because, remember, all we were thinking about was the case where the camera x-axis is always the same. So the camera x-axis and the world axis are the same. So the only change is the y-axis, whether it was actually pointing, and in this case it was the z, we've changed it to the z, right? Because here this transform changed it to be in the z-axis. So I should really say z-axis, right? So we're talking about a case where the z-axis points either straight up in world space or lies down somewhat based on how the camera is pointed, right? So that was really what we were doing, is adjusting that fold over. We were sort of from the side, we were saying, okay, we've got one axis that looks like this and one axis that looks like this. This is the camera one. This is the one that comes from the render group. And this is the world one, right? This is the one that's just 0, 0, 1 always, okay? And we were blending between those to get sort of a hybrid amount of laydown for our sprites, okay? And so the problem that we have is that we still want to produce this lying down effect, but we don't want to produce any rotational. We want the x-axis to always be the camera's x-axis. So the problem that we have is the fact that this is wrong. The way the x-axis is going is wrong. We want this x-axis to always be our x-axis, and we want the y-axis to be the only thing that's changing, right? Hopefully that makes some sense. Now, what we could do is we could say, all right, well, that's pretty easy, right? That just means this is always 0, right? Like, done, right? Problem solved. So now we get the lay down effect, but we also get the facing the camera bit, right? Although as I'm looking at it, it doesn't look like we do. Why not? Oh, sorry. Wrong one. We always want the cameras. And so that would give us the correct sort of lie down effect where we want a hybrid in terms of the lying down. I should put the trees back in so that we can see it because we're using grass, which is kind of small. Let me go ahead and put the trees correct here so that they can continue to do that. So I'm going to do a push up right here. And let me just make sure this is correct. I think that'll just work. And so what you can see here is now the trees are rotating to face us, which is what we expect to have happen when we move the camera. But the trees also are doing a little bit of the tilt that they should be doing, right? And that's what we want to see happening. Now, unfortunately, it's a little hard to see in this case. So I do think we want to maybe try to construct a test that will let us know to what extent we're doing that correctly, because we may still be doing it slightly incorrectly. And I want to figure out a way to make sure that we're not. Like, it's hard to really see whether those trees are tilting up as much as they should be. And I don't know. Let's maybe see how they look when they pan. I guess the other thing I could do is just draw some more, like an upright, just rectangle kind of a thing, and see how that looks. What just happened? Looks like our panning is busted. Oh. That's not supposed to be a plus equals. That's just supposed to be an equals. So here, where we've got the camera offset, and we're setting that here, the only problem is that will overwrite the drop shift. So I feel like we didn't have a good way to really set that up. This kind of needs to be an additional offset kind of a thing. So I'm not sure what to do about that, how we want to do that. I feel like almost the drop shift needs to be something specified separately. So let's just do that. Could do an offset and a shift. And so here what I could do is say, all right, the result offset equals 0, 0, 0, and the result shift equals that, where we actually have the shift in there. And then when we use the offset, we'll just add them together. That way, this can just cold set that, and it will always still have the correct one. I want to switch. I want here this camera panning. I want to start with panning because I think that's going to make it easier for me to see. So rather than have to wait for it to do its rotation, I want to see the panning as we go, and just see if it feels like it's doing its shifting properly. And it's kind of hard to say. I really don't think I'm going to be able to tell. So I think I'm going to have to draw like something that's a card. Like I'm going to have to draw something that's like more rectangular so that I can see. So I'm going to replace the tree with a wall texture for now so I can see if it's actually getting a curve to it, because I want to be able to debug that function and I feel like I won't be able to. Yeah, so that's not getting a curve to it. And so my question is why? Because I feel like it, because I didn't set the t value back to 0.25, which is what, yeah, there we go. So now I can see very clearly, you know, getting that sort of tilt to the side. And then if I look at the rotation version here, let me just set that to false. And then when we look at the rotation, it should still face the camera. But this is still not going to be quite right, and we'll talk about why in a second. So now you can see that the cards are clearly facing the camera, and they clearly have the sort of slanted vertical lines that we expect them to have, and so that's, you know, that's exactly what we want. So why am I suggesting that that's not sufficient and that we have a little bit more work to do? Well, the reason I think we have a little bit more work to do is because this assumes that the x-axis and y-axes are 1 and 0, right? Now, if we weren't going to use those, so if I try to twist my tree around, we'll just get complete nonsense, right? So here's an example of what happens. Let me go ahead over to the renderer test and ask it to output a tree that has some kind of a rotation to it. So, you know, we'll say, all right, our tree color is going to remain white, but now I'm going to specify 2 axes like this, right? But what I want to do is I want to rotate the tree a little bit, right? So I want to like make the tree be sort of skewed over, right? And furthermore, we allow actual skewing and stuff, so these don't even have to be unit axes. So let's suppose that I just said, all right, the x-axis from now on is going to be 0.5f, 0.5s. So it's actually a diagonal going off to the side. And then the y-axis would be negative 0.5f, 0.5f. So it's the kind of, so now like we're kind of making a diamond shape. Well, not a diamond shape, but you know, like a 45-degree rotation and some scaling in there, right, as well. So there's our scaled folks. And what I hope you can see, I don't know if you can quite see it entirely, but what I hope you can see is now we're getting some wrong results, right? Do you see how they're kind of twisting? Like, it's a little subtle, but you can see the size is changing and they're collapsing a little, right? And that's because, right, you can really see it now, right? Hopefully you can kind of see how it's collapsing that. That's because we just made assumptions about what the axes were. We're not supposed to be doing that. The x and y axis that we get passed in are supposed to be sort of what you want your x and y axis of the sprite to be in the camera plane, in the view space, right? So you're supposed to be able to pass whatever you want in there, and all we're supposed to do is make sure that it lies down a little bit to get some of that perspective foreshortening, but otherwise it should always be in that plane. And we're definitely not doing that right now. So what we need to do is we need to make a construction here that does that more correctly. Okay. So if we take a look at what's going on in this construction, what we can see is that really this axis here, we really want to construct this other set of blend axes. So we know that these always face the camera, right? These are constructed purely from the camera. So we know that these two axes are just always correct as far as the camera axes are concerned, right? That's what they always mean. But if you look at what is happening here, what you can see is that if you look at what's happening here, you can see that these two axes are always constructed with built-in assumptions about what is the X and Y axes. It should be, the X-axis in this case is always constructed as if it was the world X-axis, and it doesn't think about any rotation that might have been with the camera. What we know is that we always want the X-axis to be following the camera. So we still want this X-axis to be a construction based on the camera's X-axis. But furthermore, this Y-axis, right? So this right here is a way of shortcutting that, which we kind of did, but this right here is assuming that the Y-axis is also in that same way always going to be aligned with the world Z-axis, right? And that's not necessarily going to be true. So what we would rather do is have a way of constructing, first of all, taking the camera version of this into account. We would like to take into account with the camera, what would a slightly lied down version of this thing look like? So that's all we're trying to do, is do that slight lie down, right? And so what I think we want to do is fundamentally change the way we're constructing these things in the first place. Rather than using these axes that are passed in at all, I think what we want to do is construct our basis first, that is a slightly lied down basis, and then do the construction directly. So I think this is what I'm going to argue. When we actually go to construct the X-axis, Y-axis thing for our sprite, this is actually how we want to do it. So this is like our hybrid X-axis, right? Oops. I won't do it. I want this. So we imagine that we've created some kind of hybrid axes here, right? And these hybrid axes are going to be the slightly lied down space. So it's just the camera axes lying down a little bit, right? And then the reason that I want to do it this way is then that takes these passed in axes out of the construction entirely. Because again, we don't care what they are. We want the user to be able to specify those any way they wish to spin their sprite around or turn it upside down or stretch it out along the X-axis but not along the Y-axis. All of those crazy or skew it. They want to do whatever they want to do. So let's just apply that at the very end. And then what we'll do is we'll just tune this one part right here to take into account the slight line down that we actually want. Okay? So that's what I'd like to do. So this can go away. Did we eliminate that correctly in this case too, right? We did, yeah, that just is the size part there. So that's good, that can stay. So what we want to do is create our axes here where we basically make through whatever it is that we're going to do, and we'll have to figure out what it is that we want to do here. We want to figure out what these are. And I'm going to say ahead of time that the X-axis, right, like I said, the X-axis always wants to spin with the camera, because this thing should always be facing the camera. The only thing we want to do is lie down a bit, so it's only the Y-axis that will ever get a lerp to begin with. So what that lets me know is that our X-axis, we know what it is, right? Our X-axis is just the X-axis from the camera. I guess I can leave this in here. Oops. Where'd that go? There it is. I guess I can leave this in here. But our x-axis is always this. And so what we're really talking about here is how we're going to get the y-axis. Because our x-axis is just known. I'm having a bad cut and paste day. Right? So when we construct whatever we're going to construct, we know that our x-axis that we're going to use is always just the camera's x-axis. Because no matter how we look at this thing, we never want it to do anything about the rotation around. Right? So that's always aligned with the screen. What we do want to do is take the y-axis, which is the upward one that runs along the upward direction of the screen, and lie that back into the screen a little bit. So the question is, if we want to lerp these things together, and I don't know that we want to lerp them. We may just want to rotate it into the screen a little bit, so I'm not sure which one we want to do. But let's suppose we stick with the lerping. How would we create an axis that's more lied down, right? Like, what would that look like exactly? So that's the question, right? And so let's talk about some simple ways we could do this. First of all, we know where is the basic. We know what the basic camera axis would be, right? We know that this is what it would be if we weren't going to change it. So if we were just going to make it so that the camera, it was a perfectly camera-facing sprite card, we know that it would just be GameXForm.y, because that's just exactly what the screen's y-axis is. And then if we think about what we might want to do to make this axis lie back down to the screen, what we could imagine is, well, okay, what if we just actually did exactly that? We said, look, we know that the z-axis, right? Well, the z-axis points back at us. So if we were to subtract some amount of z-axis from this thing, it would push this axis back into the screen, right? And just to show you what's happening there, so for example, if here is our camera, here's the screen, so we know that our y-axis, this is our camera y, right? So this is the one from the game transform. So if this is our camera y, we know that this is our camera z, because the z always points back towards the camera. So if we were to subtract some amount of the z-axis, right, that would push this back into the screen some distance. And then if we wanted to ensure that this thing was normal, we could normalize it to shrink it back down to a unit axis. We could also not normalize it. The choice is up to us, right? But what I'm going to do first is I'm going to normalize it. So I'm going to say, let's try that first. And let's use those as our bases, right? So let's start there. And I may have to debug that a little bit. But let's start with that as the construction we're going to try. And what you can see right now is we're getting that facing, which we want, where they are turning to face us. And we'll turn them upright later to make sure we're also getting that slant. It's really hard to read the slant on something that, in fact, is already, rotated. But you can also see now we're not getting that collapse that we were getting before. So you can see how that's an improvement there, right? Like that's looking right now. Let's tilt them back straight up. So let's take out the part of this that was passing different axes. And let's make sure we're still getting a pleasing amount of perspective in there. And we'll see how that goes, right? And I'm not sure about that. Let's switch to panning. I should make a key that lets me switch to panning, because I feel like we're doing it enough that it's a pain in the butt to have to change it every time. Oops. What am I doing here? I want it to render test, but I'm not getting it. Oh, because it's right here. That's why. So, you know, now that I think of it, though, we are never quite going to get the slanted look we're looking for with the way I'm doing this, because that y-axis is still that y-axis really needs to tilt more towards the world z-axis in order for it to be more upright. So I kind of don't, that lie down is, I kind of thought it through wrong. That lie down, although we made a good function for doing the lie down, that was quite nice. That's not really what we needed there. So it's more like we just want to shift it towards the world z-axis, I guess. Which would look like that. Right, so I'm just there blending it towards the world z-axis. And you can see now we're getting a little bit more of that. I don't know that I'm getting enough of that. And also, I suppose this has to be normalized, right, as well. I want to make a normal in that direction. And we'll see what the t value should be. I'm not sure what it should be yet. We'll take a look. I'm going to probably increase it a little more than that. Let's see what happens if we blend halfway between those two. So I feel like that's getting a reasonable amount of that in there. Let me just check to make sure our construction is sound. I'm going to try cranking it all the way so it's just using the world z-axis to make sure that we just end up with flat cards. That looks about right to me. Yeah, I think that's correct. So the question is, to what extent is that good or bad, right? Like, I don't know how, and I think that might be sort of an artistic tuning issue. So I kind of feel like maybe this t parameter would want to be controlled by the artist. You know what I'm saying? Or the programmer in an aesthetic sense. Meaning, I don't think we want to prescribe that. You know? I feel like that's something we're going to want to tune. That's my assumption. So if we switch back to the trees here, because I think that's probably what we want. Again, very simple, but I think it's correct. I think it's a reasonable way to parameterize it. Oops. I don't know why I did that. That's not what I wanted to do. Although I do want to test that. Let's actually test that real quick. Make sure we don't get any collapsing here. I don't think we should, but... seems okay. They always seem to retain a reasonable amount of their, you know, their surface area. So if we go back and switch to the tree texture here, here's what it looks like with the trees currently. And, you know, I don't know, again, to what extent that T value should really be tuned, you know, when we're looking at it. Rotation never looks particularly good with sprite cards anyway, so I don't know that we care too much about this, but, you know, it's the kind of thing that we should at least support. So let's suppose we set that T... Ooh, okay, didn't mean to do that. Let's suppose we set that T value to 0.5. So here's one that has like sort of a bit of the attenuation and a bit of the camera in it, like half and half. And I feel like that looks like a pretty good happy medium between the two. But like I said, maybe we'll sort of specify that blending parameter as a call to the function so that people who are doing this, you know, to the extent that they want to tune this, they can sort of play with that T parameter and get different things out of it. I also think that we probably want the Z bias to be parameterized on that same T, meaning that if this sprite card was directly up and down, you would not want to apply any Z bias because the Z sorting is actually 100% correct at that point. So I think what we want to do here is say, look, when we lerp this thing, we also kind of are lerping the Z bias, right? And so the Z bias is going to be based on this T value. It will go up to, you know, it will get to that amount at the point where you use the least amount of blending. So because this T value is sort of the other way around, trying to think of how I want to say this. So, you know, the T value is going to go from one of these things to the other. And if we phrase the T value such that it goes from the like world Z, which is this, to the lerp Z, which is that. If we phrase it that way, then I feel like we'll end up in a situation where we get this parameter being more natural for the Z bias as well. Because now the Z bias increases as you go towards the camera y-axis, which is what we want. Now this value, although, you know, one thing that's worth mentioning is the degree to which those axes need biasing in them is probably also kind of different. So I feel like this parameter might have to be tuned as well, although we could possibly solve for it based on the difference between the y-axis in the camera and the z-axis in the world. So this, you know, parameter here could really be based on the difference between those two things. And that seems actually kind of reasonable to me. So if we assume that we have a world up vector here, I kind of want to say that this value here is like the inner product of the world up vector and the, you know, and the camera up vector. Wait, what just happened there? How did we end up with, wait, what? How did we end up with the lerp around that? Somebody tell me what's happening here. That's an error, right? Yeah, okay. I'm having a bad cut and paste day. I've said it once, I'll say it again. All right. So if we go from the world up vector where we would not need any bias to the GameX forms Y, right? Then if we imagine this is the camera up, we can sort of make this a little clearer what we're doing here, where we're just blending two up vectors together to get a different up vector. So assuming that we blend these two together, now we get a situation where we sort of where we know we could produce a measure of the need for bias by looking at how those two vectors relate, right? And so if they're pretty close together, we wouldn't need much bias at all because the blend isn't going to change the Z buffering. But if they are, then we do, if they're quite different. So, you know, I'm not sure about that. We should probably put to do in there to like tune that value more as necessary. But like that seems like a pretty reasonable approach to me. And I don't know whether it should be the inner product or not. Or if it should be more of a distance measure between the two vectors, because one of them falls off with the cosine and one of them falls off without it, right? You could linearize. I could also inverse cosine, or you know, approximately inverse cosine that. And so it's hard to say like which that should really be at the end of the day. Okay. But I'm reasonably happy with that, and yeah, I think that's probably okay. All right. Okay. So if we just want to leave it like that, which I think we do, then the only real thing we need in here is the ability to specify a t-value, right? So what I want to do here is say, look, that t-value can be adjusted. So if you want to specify the t-value for the flattening, this is the thing that controls like t camera up, and we'll set it to 0.5, and we'll use that everywhere, right? And that's the blending that ends up getting done per sprite if you'd like. So different sprites can like lie down to different amounts if you need them to, and off you go. I think that's pretty much everything. That all looks good to me. So a couple other things that happen here that are worth noting. So one is I feel like the render group should have the world up vector in it. So, you know, in case we ever want to change that, I just want to see like, you know, in here, we don't reference the z-axis anywhere, it looks like. So I think this is the only place we're talking about world up. So I think what we might want to do is say, look, when you specify one of these render groups, you can specify what that world up vector is. Maybe it's in the render transform. It's hard to say whether it should be or not. I think it maybe would just be something that'd be set in here. You know, so maybe there's like a world up vector that's set in here, and everyone uses it. And then when you do a, you know, begin, when you do a begin render group, we'll just set it. And the only reason for that is in case we want to be able to support in the future changing the world up for other people so it doesn't have to be the z-axis. This would give them a convenient place to do that. That doesn't, so the rest of this stuff doesn't break. So then you would just use like, okay, here's the world up vector, right? And then when you actually do a begin render group, we would just set it inside here as part of the settings. And then we would never change it, and most people probably wouldn't because they'd be following our conventions if they're using our renderer. But if they wanted to do that, they could, and that seems worth doing. So I think that's basically it for those calls. I don't know what else we would need here. So let's think about these calls a little bit. We pass the texture, we pass the ground position and the size, and then optionally color. So I think that works pretty well. I don't really see any reason to complain. So my next question is, well, cubes, right? Cubes are going to be potentially a different story. So when we're sending cubes down, the question is, how are those specified? And it looks like they're just center and out, center and radius, and then we have a color. At the moment, they also have an emissions value, which seems fine as far as storing lighting is concerned. And I think that'll just be something we'll address a little later on. So I think maybe the cubes are fine. The only question I have is, so this thing right here, where we have these sort of like texture coordinates for everything, I feel like that's something we want to have as a fully programmable thing. So people are going to want to control the texturing of these cubes a little bit more than that, including us, like not just other people, but us. So I feel like we want a struct here that's like struct cube texture layout or something like that. And if you imagine taking these things and putting them in here, just so we can specify what all these texture coordinates should be. Oops. So if we look at the cube texture layout, we kind of need like a fully like articulated set of UV coordinates for this thing. And these have to kind of be programmable in a way that fully says there's 6 faces to a cube, top, bottom, and then 4 around the ring. And we probably want all of those, right? So when we go to talk about the mid here, mid, we probably want to have those actually be like mid 0, mid 1, mid 2, and so on, right? And I guess I'm not sure how we want to talk about those. Like, maybe plus x plus y, negative x, negative y. So maybe it's like, hey, this is 0. This is 1. This is 2. And this is 3. So, the thing goes, like that, I guess. Now, I don't think I can actually do that quite yet because I think these are actually dependent on the way we do boxes. So I think because of the way we're doing lighting at the moment, which we might change in the future to make it. I hope our lighting gets better, obviously. I think I'm just going to leave them in that order, but that's the order that they're going in now in terms of the texture coordinates. So you could imagine each of these here now as being something specified separately. And then what I'm going to do is just say, okay, let's suppose that we then create sort of a cube texture layout thing here that's like the default cube. And the default cube looks like this, right? So you start by saying what the bottom ones are. You then say what the mid ones are, and this is just an array of 4 of these, because right now we're not actually going to use different coordinates. Okay. And then finally the top. And then what we could do is say you pass one of these cube texture layouts into the function for when you want to specify what the cube texture layout actually is. So, you know, maybe I'll call this UV. Like that. So you'll say cube UV layout. You'll pass in one of these. By default, it can be the default cube, right? But you can also pass in your own cubes. And then in here, when we look it up, we'll just read out what these values are. So the UV layout will come out of here. And it does seem, so if we ever changed to using instance stuff, we could also instance this because it's going to be repeated pretty often. Probably. Just thinking that through, it's like you could pretty easily use a lookup table for this. So I'll just say because really this is going to be self-similar a lot, so a lot of cubes are going to have similar UV layouts. So sending down all of this stuff as individual things doesn't make a lot of sense in terms of optimality. Like if we're just trying to think about how you would make an optimal renderer. And so I don't know that I ever want to go down that kind of route. Like Handmade Hero is not going to have an optimal sort of hardware renderer because it's not really supposed to be something where we spend all of our time doing micro optimizations on the renderer. Because you can spend an eternity doing such things. And the problem is that, because hardware support is what it is, you end up in situations where you have like 50 different paths in your renderer depending on what sorts of things the hardware you're on supports. And I don't know that that's a particularly useful thing for us to be doing, right? But it's worth putting the to-dos in because at the end of Handmade Hero, what I would like to do is sort of have a list of like, hey, folks, if you're looking for programming exercises to do, here are the sorts of things you could do, like add a path to Handmade Hero that's optimized for geometry shaders, right? And then you have a bunch of sort of notes in the code that are there to let you know, here's a place you could improve the performance of this thing, and here's a way to try it, right? And I think that'll be good for people. So even though I don't necessarily plan to do some of those things, I feel like they are useful in the sense that they could be good for people to know where they can make those contributions, or and then how, right? All right, so let's go here. Cube UV layout. I think that should do it. So here where we're pushing the cube on here, we're specifying all the parameters here. So if we want to do that, we would have to do the default cube. None of this stuff is necessary. Like the emission value will default to that anyway. So I feel like we can just get rid of that, and that would solve that problem. Let's see here. Emission light store. This is default cube. I'm going to change that to default cube UV just to make it a little bit clearer. Default cube. There we go. Oops. This should be default cube UV. And so that just lets us change the UVs of the cube a bit as necessary. And so, you know, we can construct different sorts of layouts for the cube UVs if we want to at that point. And, you know, maybe we do want to, right? As you can imagine us sort of making walls out of these things, we might want to use the different parts of that texture to kind of slide around and make different ones. So just to underscore how that works and to make sure that the change we added actually does work, you could imagine us doing like in here, all we know is like that something is element wall, let's say, right? That's the only piece of information that we actually have. But let's suppose we have like element, you know, wall start and element wall end, and these are just like different types of little wall pieces. It's not going to be correct because we're not really going to do anything with that, but I just want to show what that would look like. So if you imagine us taking that default cube layout here and just placing it into our own system, what we can do is say, all right, when we're going to draw one of these cubes, there's a couple different cube layouts we could use, and maybe they're just parameterized on this. So, you know, we just make them line up with this thing or something, right? I don't know. We don't really have to do that. We could actually do it just fine. So we'll do like wall UV is this, and wall start UV is something else. So in order to do the wall start UV, these values would shift over. So what you can see here on the midline is it's basically just using 0 to 0.2.5. So the wall start, I believe, is just this, right? It's just a thing that shifts it over by 0.25, and that's literally it. There's nothing else that has to happen. We're just shifting those texture coordinates over to pick out the next panel in the packed wall, and that's right. It's nothing special. And wall end is exactly the same as well. The top and bottom don't change because those don't change at all, right? But the same would be true here, right? We're just sliding it over to pick the last one, and that's all we're doing. And if we wanted to get creative, you could see also generating these with a macro pretty easily because, as you can see, they're exactly the same values. The only difference between them is what you specify as the x coordinate in the mid. So anyway, so that's wall start and wall end UVs. So now if I built this, you know, no one would care because it doesn't matter to the code at all currently, but let's suppose we made it matter to the code. So let's suppose when we do place rectangular wall, and then what we do is in here we say, you know, here's the thing that places what it is. If the y, so the y doesn't place end pieces, but the x does. So let's just say if the x, I'm gonna do a little test here to say, look, the scene element lm type equals element wall, and I'm gonna place lm type in here, and then I'm just gonna do a thing that says, look, if the x-axis is at its min right now, then the lm type equals element wall start, and if the x equals max x, then the lm type equals element wall end, right? And so that just gives us the ability to set those. Now, when we set those, again, we're not actually using those UVs anywhere. So what we do have to do is when we actually test these here, we just kind of need to say, like, look, this can loft out. We need to be able to pass different stuff in here. So we need to be able to say, like, okay, this is going to be the default cube. Although actually we made one for these. It's just wall UV, right? But what we can do here is dispatch on this thing and say, like, look, if it's a wall start or a wall end, we can do something different here. Wall start UV, wall end UV. And now we're drawing potentially 3 different types. Like I said, these aren't going to line up at all because this is not how you would actually do this. But it should just let us see, like, right, that we're getting one of these in each case, right? And that's all I was trying to do. So just to get that basic, you know, sort of start and end look in place. And as you can see, they go the wrong direction depending on which kind of thing you were doing, because we didn't actually do, you need to figure out which face you're talking about as you go around it. So it's going to be right from facing forwards, it'll always be right, but from all the other directions, it'll be wrong, right? Because of just the fact that we didn't set those up. So that's all that is. And we could also go ahead and change this one now to actually use the mid-wall version. So in here, like when we do this regular wall UV, this one actually wants to be 0.5 to 0.75 because that's the one for an actual wall run as opposed to a wall end. So we can do that as well. And now we know that that's working correctly, unless I'm missing something. It's not a very complete test, but it's good enough one for now. We can count on the person calling the renderer to be able to texture their cubes however they want to texture their cubes, which is what we wanted. And so now, like, yeah, and if you look at it sort of, you can see it from a, if you had all these be the same height, they would kind of line up, right? I don't know. So that Z rand, we actually want that Z to not be, so another thing we probably should do there, just to test it, is this Z value should really not do what it's doing here. So when we do this push cube, I'm going to move this over. Well, you know what I'm going to do? I'm going to just do it this way. I'm going to say it's going to be equal to 0.0 if it's a wall. So if it's any of these, and I could just make an isWall function, but I don't really care enough in this. This is just the test code. And that just will line all the walls up so they're like an equal height, right? And so you can kind of see how that all kind of comes together. Similarly, I don't really want the wall colors to vary. So this R, I don't really want to have happen either. So one way to do this actually, I suppose, would be to do it like this. And then say, okay, you can set these to their normal things, but z equals 0 and r equals 1 in the case where this thing is a wall, because I don't want you to be doing all kinds of funny business. And then you can see kind of making that segmented wall, but it lines up now, So that's all I'm talking about. And I think that's basically it. That's really all there is to that. That's all I wanted to do. And so now we kind of have a more complete test of that, and that's all good. So camera is panning equals true. I'd like to take a little look at the panning version, but then I think we're pretty much done here. Maybe I'll even go the extra mile. Who knows? And push those up a little bit so that I'm just gonna give it a little bump here. So that is, I think, pretty much concludes our work with the renderer in that sense. And I think we want to move on to the texture situation. And I guess we could also take a little bit of a quick benchmark, just a really brief kind of like just a quick temperature test to see how slow we are with the texture changes, and maybe we can go in and sort of nerf the lighting computation in the pixel shader as well, just to see if we can't get an idea of what our of how expensive our texture changes are, so that we know if we've done a good job getting rid of them. You know what I'm saying? So I feel like this is good. Just going to let it run through its paces here to make sure nothing untoward is happening. But I think we're good to go. So I feel like that's all good. So what I'd like to do now is I'd like to go ahead and test some of the texture change stuff a little bit. So we have a way to stress it out already. And the way we can stress this out is just by, when we push our simple scene on, we had a way of doing a lot of grass cover, right? It's this thing. So if I just dump a ton of sprites in there, we get a lot slower. And there you go. You can see how slow we get in this case. And I'm sure we can slow us down even more. Just push an arbitrary number on there until you get slow enough. Right? And what I'd like to do is find out how much time we're spending in different parts of the pipeline here, to just to know who's at fault, because I would like to get us into a position where texture changes are the expensive part before we optimize our texture changes. You know, just to make sure that we can actually, you know, see what we're actually doing. So let's try. I know it's always a sort of a. I know it's always an exercise in frustration to try to use any kind of anything that has to do with the GPU is always bad. They're horrible. They're not built like CPUs. They don't have proper debugging. They don't have proper profiling, and it's awful. We know this, but let's just see if we can get some measure of that going. And hopefully, maybe, I don't know, we'll be able to do something where we can at least say, look, here is how much those texture changes are costing us, and, you know, they're bad. Now, I don't know if we can make that happen. You know, it's speculation on my part that it's ever even going to happen on an NVIDIA part, because NVIDIA parts are good at texture changes. So it's hard to say whether this would really be the case or not. I don't know. So we're going to try. This may not help, but we do need to do that stuff for texture changes anyway. Why am I not able to? Oh, this is the new project, right? Okay. So I need to basically make one of these things. I am gonna make this inside Handmade MSVC proj, and I'm just gonna make the Win32 renderer test thing be what we're doing. I'm just gonna call it that because I don't know what else to call it. I'm gonna pick the executable from the build directory here. And as far as the working directory is concerned, I don't remember what we set the working directory of this thing to. So I'm just going to look. So I want to make sure we always run it the exact same way. So it's in there. So we're going to tell it to run it in there. And that should be it, actually. So hopefully we can make this run. What? I don't know that I really care about this. I guess I don't know if this needs to access the network externally, because it should only need to use loopback. So I'll just try not allowing it through the firewall first, and we'll see if that actually poses a problem. So it seems like it doesn't need that. So I'm just going to skip that. I assume that's just for remote capture. So what I can say though is, you know, I'm just testing to make sure Insight's working. It seems like it maybe is working. I don't know. It's taking a long time to capture the frame, but that's probably just because there's a lot of dispatches in there. So what I assume is that we're really not seeing the texture change hit that much at the moment, because if I looked at the, you know, if you look at the little graph that was on the overlay on the HUD, it was showing that the texture part was was getting overstressed, right? Or it looked that way. So I'm not sure that we're really going to find that our current problem is texture changes. And we've got some things that we probably need to fix, like the fact that we're relying on multi-sampling everywhere instead of only in one pass, and a bunch of stuff like that. So there's a number of things that we probably want to do, and we'll see what we can do. We will see what we can do about those later. I don't really know what it's doing right now. but here's my guess. Because we issue so many draw calls, I'm guessing that it's like doing a replay and doing a screen capture of like every dispatch. So we're going to end up with like 8 billion little tiny screen grabs of like one piece of grass drawing. You know what I'm saying? So ironically, although I'm not sure that the actual dispatches are the problem at the moment in our actual code, well, they probably are the problem in our capturing. For whatever that's worth. So one thing we can also do is, because we draw so many grasses at once, we could also do a thing where we just check to see whether the grasses are the same grass and draw them in a batch as a test, right? As just a way of seeing whether or not this is the case. This looks like we could be here forever. I'm not anticipating this is ever going to finish in our lifetime. So that's fine. Like I said, working with GPUs is terrible. It always is. It's the worst part of the job. So yeah, not sure what to do about that. I'm going to go ahead and close this stuff because it's not working. And I'm going to go ahead and investigate this a little bit differently. Like I said, you can never really... GPUs are awful. Yeah, kind of wish they never happened. So let's go ahead and pop over to the renderer. And what I want to do is I want to just look at where we're doing those dispatches, and I'm gonna fake some code in here to aggregate batches before we actually do the work of aggregating batches, just so we can see what the difference is, right? That's all I really want to do. So let's start with some of that, right? And we can go from there. Excuse me. Where's our stuff here? There it is. Like, where's our dispatch? So this is where we dispatch everything. And I just want to see, so when we do our drawing here, you can kind of see when we do, what we end up doing is we draw one triangle strip and then we have to restart, right? And the reason that we have to restart our triangle strip is just because there is no way to just send quads down. Like, for some unknown reason, they got rid of quads as a drawing method, and I don't know why, because they are very efficient for drawing sprites. And I guess their thinking was just, well, use a geometry shader. And output them that way. I don't know. But the problem that we will have is that by calling GL draw arrays, there's really no way for us to draw multiple quads without doing more fancy footwork here. Now, what we can do is we can sort of start to construct something that would allow us to draw these quads in a way that that doesn't incur much of a penalty. And that would be by actually having an index buffer that tracks as we sync the quads, that sort of tracks that. And what I want to know, because I don't actually know, is whether primitive restart index actually exists at the moment, in terms of like, let me see here. So primitive restart is not an NV only thing, so I'm guessing I maybe like have the wrong name for it. So I'm not sure how to search for that because it was part of core, and I'm just not sure when it went in. But quite a few cards have it, right? So I feel like it's a fairly highly supported feature, but I'm just not sure. I don't know about how much coverage there is for primitive restart. But basically, what you can do is if you, and you know, now I think about it, I guess it doesn't really matter. I mean, it's going to save us only one index. But what you can do is if you want to do something like send down quads, you can use a tri-strip to send down 4 quads, 4 vertices that form the quad, and then a restart element that says, okay, I want you to restart the tri-strip, right? So we could do that. But in order to do that, we have to switch to having an index buffer in addition to a vertex buffer. And once we do that, we can just send down quads as 6 indices, 1, 2, 3, 1, 2, 3, and be done anyway. So we can probably just switch to that and be fine with it. I'm interested to try that. So what I would like to do here is instead of GL draw arrays, OpenGL dot, what's the doc? It's like OpenGL doc. It's like a docs.gl. That's it. I'm like, it's got a good searchable one. So GL draw arrays, if you look at how it's called, it just assumes that you're going to point to an array of vertices somehow. And those vertices are going to be interpreted in order. And what we'd like to switch to is being able to send down vertices and then indexes into that vertex array. And so if you look at how this is batched here, what we'd like is a call that allows us to specify an index buffer. And so, don't ask me why that did that. Okay, there we go. And so I believe this is the name of the index buffer one. I never remember. Yeah. So if we want to, we can call draw elements and pass an index buffer as well. And so when we call this GL draw arrays, we can instead call GL draw elements and pass an index buffer down. So if we wanted to, for example, we could do that right here, where what we could say is, look, instead of that call, let's use this call. And then when we do mode count type indices, same basic idea. We want triangle strip. Actually, no, let's do GL triangles instead, right? The number of indices we're going to send down now, because this count here, like the number of elements to be rendered, before we're doing 4 vertices, we're going to do 6 indices now, okay? We're going to say what kind of indices we're sending down. Let's send down unsigned shorts, more efficient. Int is good. Is probably what we want for right now, because we don't want to have to break things up into bunches. Let's break them up into bunches anyway. So let's do short. Let's get our short on, and then we want to pass them down. Okay. So what I'm going to do is I'm going to draw by index. I'm going to create some indices here, and what I'm going to do is just create the indices that would take 4 elements in tri-strip order, and I'm going to use those as indices to draw actual triangles myself, okay? So a tri-strip is 0, 1, 2, 3. That's how it's constructed to draw a quad, 0, 1, 2, 3. So what we want to do is if we know we're getting 0, 1, 2, 3 down the pipe, I'm just going to draw 2 triangles, right? Well, I should actually draw them this way. So I'm going to draw 0, 2, 1, and then I'm going to draw 1, 2, 3. Okay, 2 counterclockwise wound triangles out of that buffer. And again, exactly what I just said. 0, 2, 1, and then the other triangles will be 1, 2, 3. All right.
And so we've done literally nothing useful here at all, other than transform, switch between. All right, and we didn't even work. Why did we not work? That seems pretty straightforward, doesn't it? Triangles, we want 6. What is the problem here? 0, 2, 1. I did have that right, yeah? What's the tri-support? It's not downward, is it? It's not that, is it? I honestly don't remember what order they go in. I'm gonna look it up. No, it's A, B, C, D. I have that right. It's exactly as I drew it. 1, 2, 3, 4. Don't ask me why they're drawn winding clockwise, because that is not... Oh, because... Alright. They set them that way. For some reason. Oh, wait, so this is only if it's clockwise, though. So are they... So it is the upside down way? I don't know. Someone show me what the actual order is. Where is it? Just show me the spec. Why am I even looking at this? I don't care what anyone posts on the web. Show me the spec. Here we go. 1, 2, 3, 4, 5. Here is the winding. 1, 2, 3, 3, 2, 4. So they actually put the triangle out in clockwise order? Is that true? I'm kind of dumbfounded right now. I don't know what to make of that. Anyway, either way, this is sort of irrelevant here, but I don't know that that's actually our problem. If I GL disable GL cull face, I'm just curious what happens. Because we didn't see anything. So that suggests that it's not just our winding order that's wrong, right? Something else is wrong here. I just don't know what it is. So I don't think that's actually the problem. The winding order is a separate issue. So I'm not sure why our draw elements call is erroneous here. I did say unsigned short, and I specified unsigned shorts. I did say I wanted 6. Oh, it's how many elements, though. Not how many vertices. Where's our draw elements call? What's the count in this case? This can make construct a sequence of generators by successfully transferring elements for count vertices. Right, so now I specified the right thing. 6 vertices.
So I'm not sure why we're getting... I'm not sure why we're getting hosed there. Because these two paths should be the same now. So if we are specifying these... Oops. Like so. Versus like so. I'm not sure why it doesn't like our index version. Maybe I need to use a different call, but OpenGL is always a little weird like that. But I feel like it should be fine. Because these all are basically the same thing, right? All right, so what did I screw up here? I'm curious. I suppose I don't know where we set the array. Oh. This is the problem. Sorry about that. I forgot the whole, we aren't setting the array pointers there. We just transfer down the buffer. So these all need to be offset by vertex index here in this case. So in that case, I am going to go ahead and make this an int temporarily. But we'll be able to fix that a little bit later, I think. Okay. Sorry that took so long. All right, so now, as you can see, we've got our winding was in fact backwards. I do not understand why they're wound that way to begin with, but that's okay. I'm fine with that. We're gonna still have, we have front face clockwise, yeah, okay. So don't ask me why that's the case, but it's fine that it is. We can just reverse our winding and no one cares. So if I do 0, 1, 2, and then 1, 3, 2 instead, that'll reverse the winding and we'll draw our quads in the order that we expect, and that's fine. So now we are drawing with indices here, and if we want to, we can now go ahead and say, well, and you know what, I think we're due for a break here, so what I probably should do is go to a brief Q&A before moving on. And on the next stream, what we'll do is we'll switch over to using a giant index buffer for everything, and then we'll move to a texture array as well. But let's go ahead and go to the Q&A here. Martin says primitive restart indexes in GL core since version 3.1, so we probably could do it. I thought you had to bind a GL element array buffer to do indexing. Is this not true if no buffer is bound? Yeah, so my recollection, and again, GL is kind of a crazy mess at this point of lots of legacy features. But one of the nice things about those legacy features is a lot of them still work. So when you're just kind of starting out, if you don't want to bind an array buffer, depending on whether you asked for a core compatibility context, I assume, but maybe not, I don't know, you can just call draw elements with a pointer, and that draws, it sucks the indices out of your memory at that point. So you don't need to bind one. Now, you probably want to bind one. And we're going to want to bind one, I believe. But I don't think you have to. Using indices seems to take a lot more memory if the vertex data contains texture, coordinates, normals, etc. How do you know when it's a good idea to render by indices? Sorry, I'm not sure. That statement sounds backwards to me. Using indices doesn't take more or less memory regardless of those things that you're talking about. Can you rephrase that question, perhaps? Or be more specific? Because, so, using indices just takes however many bytes an index takes. You know, in our case, it'll probably end up taking 2 bytes per index. And so for every triangle, you're going to have 6 indices to, or 5 if we use primitive restart. So you're talking about a 6 times 2 or 12 bytes per quad, right? So if you think about what would happen if we didn't use indices, well, if we want to draw a big batch, it would actually be way worse than that. Because for every triangle, we have to send down 3 sets of vertex data. So we'd have to send down 6 whole vertices, which are massive, right? So indices actually save you a lot of memory. It's the other way around, if that makes sense. I have one regarding Valbus's pre-stream question, if that's all right. Why were the next steps of investigation into the message box call not working? Try to do it with an indirect call, then next to do it on another thread. What was the line of thinking? So the line of thinking was just, I wanted to know if it was the thread in particular that was causing the problem, like which thread he was calling it on and the state that it was in. So what I wanted to do was move it off that thread. And there's another thing I want to do if it still doesn't work, which is have him pass 0 for the window handle on a separate thread. And I'm just reducing the number of possible problems sequentially to figure out which one is causing the problem. What is your opinion on texture arrays versus texture atlases? Why did you choose texture arrays? So texture atlases and texture arrays have different trade-offs. The reason I chose texture arrays is because I don't want to say mipmap properly, because that's kind of a bold statement. They mipmap better than texture atlases. So texture atlases have a particularly nasty problem, well, a couple nasty problems. One is that you can't tile your textures. So if you want a repeating texture, you can't do it with an atlas because there's no way to specify off-atlas coordinates that would wrap around into the chunk you're actually using. So there's that limitation. And the other limitation is fetching outside the atlas will actually cause you, like fetching to the side of your... fetching outside of the region of the atlas you want will actually pick up other pixel data rather than nothing. So you can't use clamp to edge. And with a texture atlas, what happens is as you mipmap the texture atlas, those textures that are next to each other blur together and create an error in mipmapping. So you end up having to leave tons of space in your texture atlas, and you waste a ton of space that way. So it's 6 to 1, half dozen of the other, because the strength of texture atlases is that you can place things arbitrarily close together, right? Like you can, you don't have to make everything be a square, right? But the downside is, well, you sort of also can't, because when you mipmap it, you'll get incorrect results if you don't leave lots of empty space there. So it's hard to kind of, think that through, I guess, but you have to make a trade-off. You have to figure out which one you want to use there, and I think texture arrays are kind of better in that case. Does the window size have anything to do with the tuning of the t-value in the renderer? No, it shouldn't. The t-value in the renderer has nothing to do with the window size. The window size is just how big the thing appears on the user screen, but the t-value is strictly about the ratio of the height in camera space, which is irrelevant, in which the screen size is not relevant. Texture arrays require all textures to be the same size and have the same number of bitmaps, though. Yes, but that's fine for our purposes. Isn't that a significant limitation? It's a limitation, but it allows you to do a lot of things you can't do, right? Like you can wrap your textures and tile the textures, and you can get clamped to 0 properly in all cases. Yeah, whereas like you say, atlases require a bunch of pixel shader instructions if you want to do a bunch of that stuff. So, you will be slower, right? Because now you've got all these operations happening inside the texture atlas. And you pay for those. They're not free. What are we going to mipmap in Handmade Hero? Well, everything now. We will probably generate mipmaps for everything. How long is fall break going to be? I don't know, just a couple weeks. Oh, good. Somebody rewrote the dependency walker for Windows 10. Yeah, I'm down with that. Let's see. So let's go ahead and get this thing. Let's see how it does. PE view, is that a thing that views executables or something? Oh, that's a command line utility, maybe? Can't say that's looking particularly good at the moment. Well, that worked better. Do you know if texture sampling is implemented in hardware? Well, yeah, of course it's implemented in hardware. What do you mean? Do you just, oh, do you mean like, is the texture coordinates computed in hardware, maybe? That part, I guess I don't know currently. That's a good question. Texture sampling is almost certainly implemented in hardware because it has to be very fast. but I don't know about the UV coordinate editing. That's a good question. Well, here's what I would say though. Even if you implemented it yourself, you could implement it faster with a texture array than you could with an atlas though, right? Because an atlas has to do a lot of crazy checking. It can't rely on the power of 2 mipmap stuff or any of those things, so it's going to do like real divides, and I don't think it matters where it's implemented in hardware or not in that sense. Atlases are just going to be slower, period, right? I mean, because it's just it's more math to do an atlas than it is to do a texture array. A texture array is just simpler. It's power of 2 dimensionally. And so all the standard tricks apply. Like, you don't have to do any complex stuff like you would with an atlas, right? I've read the sequel asks, this is just about paradigms. What sets apart the functions you have made to construct structs certain ways, like get standard camera, from the methodology around constructors in C++ that I presume you dislike, or are they actually similar? So I guess it depends what you mean. Let me pull up an example, or the example that you're talking about, just so we're clear. So I assume you're talking about this get standard camera here. So I'll start with the simplest and most basic thing that I think is terrible about C++, right? So let's look at how this would happen in C++ with a constructor. So this is a constructor, and it would look like this. Right? So this is what it would look like if you were in C++. So first things first. I don't know if the user wants to waste their time initializing this object or not. Right? I have no idea. There's a number of ways they might want to initialize it. So in the usage code, they might want to say some number of things. These are all things I might want to say, right? I might want to say, give me whatever the default is, give me 0, give me uninitialized, right? Here's the C version. And I could even say default camera, right? So here's the C version of this thing. Here's the imaginary one that I wanted to write. And you can see they're actually fairly close, right? Where does it fall down? Well, mostly in this line. And the reason that it falls down is because C isn't smart enough to overload on this, right? So I can't do that exactly because it's not something I'm allowed to do in that way. So, you know, you're stuck with that, which is slightly less good, but it's almost the same. So now, if we wanted to do this with constructors, how would we do it? Well, now I end up in a situation where I pretty much have to make a totally separate set of typing just to make that happen, right? I can't do anything even close to this once I have constructors, because constructors are all implicitly named the same thing as the class, and there's no way to differentiate between them, right? Like this is now the only thing I can do. Period. I can't even get the other ones at all, right? So what I would need to do now is say, well, okay, I mean, I suppose technically speaking, I can do this one still. Probably. I don't really remember, because C++ has evolved a bit since the last time I ever programmed in it seriously. I don't remember it. It wouldn't have let you do this then, but it probably lets you do this now, because we haven't, like, unless we blocked, which a lot of people do, but if we blocked an operator equals down here or something, I think it would let us do this, because I think this is just an assignment constructor at that point. So either that's going to call this path, which we have not disallowed, and so which will be created correctly for us, or it's going to call the operator equals. I think it's going to call that one, the copy constructor, by normal C++ rules. So we haven't disallowed that, so that one will work. This one, there is no zero. Zero's not on the table. So the question is, I'm sorry, there is no uninitialized. So I can't just not initialize it yet. So the question becomes, well, how would I do that? Right? Like, how would I make an uninitialized version? And the answer is, now I have to make some monkey business here that I don't know. I mean, like this, I guess. So it's like, okay, you know, that's the uninitialized one, I guess. The other thing I could do is use a placement operator to, well, that doesn't really work in this case. So, like, I don't know, I don't even know if this actually works. But this one, I don't know how to get this one to work at all. Like, I don't know how to say, I'm going to initialize this later, right? But let's say that this did work, right? Even if this, or not that it worked, let's say that this was acceptable to you. This is not acceptable to me as a syntax, but let's say that it was. Or that you went out of your way to now do, like, okay, you know, uninitialize, or okay, let's say I do something less terrible and I don't know, right? Now the question is, well, now I can't even make that happen directly to this thing either, right? I now have to do, like, well, okay, let's create a new one of these and copy construct it over or something, right? Which is what I'm doing here, but it also makes it hard for me to do the other way around, where if I didn't want to rely on that, I could have done this, right? And that's nice to have that flexibility. Here, I would now have to use a really ugly placement new syntax, which is like, I don't even remember what it is. You know what I'm talking about, though, right? It's horrible. Placement new syntax. It's this garbage here. So no. Here it is. So now you have to do this absolute garbage, right? Where in order to get the constructor called, I have to do this. So I have to do new address of camera, right? To get that to happen. And then this is the type here, right? So it's camera. And then that's my camera. I mean, I guess I can just not do that, right? Which is nuts. I mean, I don't even know. Like, so you can see why this, there's no, it's not like you can't do the things. It's just they did a terrible job with that, right? I mean, it's really dumb. I mean, if you even thought about it for half a second, what you'd realize is there's just multiple phases to the things that you do to structs. You declare their layout, you provide ways in which they can be initialized, you state when and where you want them to be initialized, right? And those things should just be exposed to the programmer. None of those things were done here, right? You know, if the half decent way to do this would have been like, you know, like this. Right? And then you would have just done like, oh, all right, you know, here's the things that you can do for that. Or if you didn't like that, you could just do it like this. And like everyone would immediately know what that was, and you could have all of the options that you wanted. And furthermore, if you wanted to change it later, you could just call it, right? You'd just be like, hey, this camera here, I want to reinitialize this camera. So it's like, what's the actual camera that you're going to do? Oh, I'm going to do, you know, that. And so I don't know what you want the syntax to be here to differentiate this from something that returns the thing. So maybe you could just use your scope operator or the dot if you wanted, right? Or something here. You know, or you could do that if you wanted. I don't care what you want the syntax to be, whatever, you know, whatever you want in that case, some way of defining. Another one would be that, I suppose. But just something halfway decent would allow you to do this. Another way to do it would just be to say, look, actually we don't care. These could, like, define them that way and let them actually be those functions, and just say that the definition of a constructor is something inside the class that returns that thing, right? And then this just, it does that. It's like, oh, I wanted one of those. Then you can also do this if you wanted, right? All of these things would be better. The one they did is so boneheaded, it just, I don't even know. It's like the worst possible thing. So I just don't use it because it's just stupid. The syntax is bad. It forces you to do weird things to like try and to do even the basic stuff. Like, it's just obvious. So there's an API principle that I introduced called granularity, right? The idea is that if you have a series of operations, you never make a feature of your language or your API be that those things are removed and you have to call them at a coarser level. So if allocation and initialization are two things that happen to objects, you never say that those two things happen together. What you do is you provide a way to do one and you provide the way to do the other, and those are both good. You make them good first. Then you provide a nice way of doing them both at the same time for when that is appropriate, right? And you make all of those things good. You never start at the high level and say, oh crap, sometimes now people don't want to do them together. We don't really like that. So we'll make this weird placement new thing to sort of get around the fact, but it's kind of janky and weird or whatever, right? And blah, blah, blah. You always build up from the steps that you would do if you were doing it all manually. You always make those perfect, and then you condense up higher and higher and higher until you get to the, the highest level version of your API. But they don't do that in C++. C++ always goes the other way around. Somebody has some idea about how you should program. You should program with constructors and destructors. Later on, someone's like, hey, man, I don't want to initialize and allocate this thing at the same time. I want to do those separately. And they're like, oh, okay, here's this janky new syntax we did to fix that problem. And then you're like, oh, well, but I want multiple ways of initializing it. And they're like, oh, well, here's this really janky way to fix that, right? And they end up with this thing that is like all these different patches on top of patches to try and restore what the basic functions that you already had were that you lost when going to their new higher level feature, right? And it's just dumb. Martin said I was stuck in .NET executables in Independence Order, which it won't show anything. Okay, so it can't browse .NET. That's fine. I mean, I don't care. I don't need to browse .NET dependencies. Back to the message box pre-stream answer. Removing the filtering of message OX738 made the window appear. Huh. All right, so I guess OX738 actually does need to be there, even though it was pretty bad and slowed us down. Are you testing the renderer with the PNG asset? Do you think the renderer would have better performance with bitmap because the decoding of that is easier than the PNG one? Oh, no. So just to be clear, the performance of the renderer has nothing to do with PNG versus bitmap. Those are loaded once and then used in memory decompressed. So there's no difference between the asset, whether it's loaded from PNG or bitmap. El Kalinovich says, I'm not sure, but doesn't camera equals brackets in C++ call the constructor? I don't know. Probably they did that because it's bad, right? But I don't know what they did. Cuber Caleb says, also placement new returns a new object in terms of C++ object lifetime, so you technically need to access it through the pointer return, so it's discussing. Yeah, I mean, you probably don't actually have to in practice, but to be spec correct, you would have to be, right? Dark Epop T. Do you think you could submit a constructor like that to C++ committee? I don't know, and I don't care. I mean, getting off of C++ is a major priority for me, and so, I will not be programming in C++ 5 years from now. Either I'll be on my own thing, like our internal stuff at Molly Rocket will grow to the point where we're only using that, or I'll be on JAI, but there is no way I'm using C++, 5 years from now. I simply won't let it happen. So I don't care what the C++ community does. They're hard to work with. They've been making bad decisions for 30 years. It's like rearranging the chairs in the Titanic, right? Like they say. I mean, it's working with the C++ community would probably be more like rearranging like the ice in the martini, or well, you probably don't put it in martini. Rearranging the ice in the lemonade on that of someone who's holding a glass of lemonade on a deck chair on the Titanic. Like, you're not even going to move the chairs. You're going to be able to get like an ice cube moved around, right? So yeah. Also, I'd like to say some meta thing about that. So one of the things also that this is a meta thing that I find kind of annoying. So a lot of times people submit something to the C++ committee thing, is a similar statement to one that I find equally sort of misguided, which is a lot of times if you're using something like a commercial product like Visual Studio, and I'm like, this thing sucks because of X, they're like, well, you should have reported that or something. And I think that's kind of just fundamentally annoying to me at a basic level. And the reason for that is because I don't want to pay you to be and then be your QA department. Like, I don't want to pay you and be your designer. The point of paying for something is that you did the work and you deliver me something good. If I have to design it for you or I have to find the bugs for you, then that's me doing the work that you should have done. And nowadays, what companies do is they offload all of the work onto their customers. I have to report the bugs, and I have to do the profiling and point out why it's slow. And I have to argue with you about why SQL shouldn't be installed when the thing gets installed or whatever, right? And that's fundamentally annoying. Like, I have a full-time job. I have 2 jobs, really, right? Arguably, possibly 3. I don't have time to fix C++. I don't have time to fix Visual Studio. I need some competent people to do something for once, right? So, like, C++ is an open standard. So I don't super blame them for being bad because they're not really getting paid in a sense. But in another sense, they are, because most of the people who do this stuff are actually working at big companies who do make money on this stuff, right? So who knows? But it's hard to blame C++ too much because, it was what it was. It's not like Java where it was a company's project or something. But something like Visual Studio is a commercial product and I pay for it, right? I actually use the professional version of that, at Molly. I don't want to be responsible for figuring out how to make your product not be bad. Like, that was kind of supposed to be what I was paying for. And so this kind of notion that nowadays it's all the community's problem and it's never the company who was supposed to just deliver something good to begin with is really annoying. And I feel like when you ship something, you should reverse that mentality. The mentality should be, we are going to figure out how to actually deliver a high quality thing, and it's not up to our customers to do that work for us. And I feel like that kind of used to be, because you couldn't patch very often. You shipped physical floppies. You were kind of forced to do a better job. Nowadays, forget it. It's just sad. Anyway, it's time for lunch. Or break anyway. So I'm going to go ahead and do that. We'll be back here, let's say 15 minutes or so, maybe 20. And we'll do the sort of the foray into seeing how to speed up our rendering and texture changes.